Yes, dear children, let us see about physical properties of elements today. To start with, we will do atomic radius first. What is atomic radius? What all types of atomic radius we are having? Covalent radius, van der Waals radius, metallic radius. These are the three types of atomic radius. Now, what is atomic radius? It is nothing but the distance from the nucleus to the outermost shell. That is called as atomic radius. It is the distance from the center of the nucleus to the outermost shell. Say for example, this is the center of the nucleus and this is the electron which is present. So this distance is called as atomic radius. Now, what is covalent radius? It is 1/2 the distance between the nuclei of two covalently bonded atoms of the same element in a molecule. Of the same element in a molecule. Now what he says that, say this is an atom and this is the other atom. Okay. Now these two atoms, they are overlapping with itself. That is, the orbitals, they are overlapping, and say this is the nucleus of both the atoms. The distance between the two nuclei is this, and 1/2 the distance is this, right? So this distance, that is, say a picometer. So that is called as covalent radius. It is 1/2 the distance between the nuclei of two covalently bonded atoms of the same element in a molecule. Now they say, for example, this is one hydrogen, this is another hydrogen. Now the nucleus of the two hydrogen atoms are joined, and 1/2 the distance of the two nuclei, distance between the two nuclei, is nothing but covalent radius. This is called as covalent radius. Right? Now what is meant by van der Waals radius? Now van der Waals radius means it is defined as 1/2 the distance between the nuclei of two identical non-bonded isolated atoms or two adjacent identical atoms belonging to two neighboring molecules of an element in the solid state. See, this radius, whenever you are measuring radius, we are referring to solid state. Remember that. Okay, we refer to solid state whenever we are measuring radius. Now what is van der Waals radius? It is defined as 1/2 the distance between the nuclei of two identical non-bonded isolated atoms. Now say this is one helium atom, okay, and this is another helium atom, and the distance between the nuclei is this, and 1/2 the distance is this, right? So now this distance is called as van der Waals radius. This is called as van der Waals radius. It may be in terms of two atoms, you say 1/2 of the distance, or it may be between, say for example, if you consider hydrogen molecules, then in that case, how do you say this is one hydrogen molecule and say this is another hydrogen molecule by the side of it, right? So in that case, you take the nucleus of this and the nucleus of this and you join this and halve the distance. So this is called as van der Waals radius. Okay, so this is what you have to understand clearly. It is defined as 1/2 the distance between the nuclei of two identical non-bonded isolated atoms. Is it not? These two are individual isolated atoms. उन दोनों के बीच में दोनों की न्यूक्लियाई को अटैच करो, उसका आधा डिस्टेंस जो है वो van der Waals radius है. If you consider molecules, then take two adjacent molecules and join the nuclei of the two neighboring atoms, and 1/2 the distance between the two is called as van der Waals radius. So you can say for both molecules as well as for atoms. But remember, it is generally measured when it is in the solid state. Now what is meant by metallic radius? Metallic radius is the distance between again it is also 1/2 the internuclear distance between the two adjacent metal ions in the metallic lattice. It is defined as 1/2 the internuclear distance between the two adjacent metal ions in the metallic lattice. Okay. Now we are talking about metallic radius and we are talking about metallic ions, metal ions. Then what does it mean? See, remember first of all what is meant by metallic bonding. What is it that hold the metal atoms together? Now say for example you have magnesium. A small piece of magnesium you are having. Say there are 10 magnesium atoms. Now these 10 magnesium atoms, each magnesium atom is having a configuration of 282. So there are 2 valence electrons with every magnesium atom. Now if you leave these 2 electrons, what do you call this? You call this as Mg2 plus. Magnesium, after losing 2 electrons, it is called as Mg2 plus. Now for 10 magnesium atoms, you will have 10 magnesium ions and 20 electrons. Each magnesium is having 2 electrons, so 10 magnesium atoms will have 20 electrons. So what is it that is holding the metal atoms together? It is the interaction between the 10 magnesium 2 plus ions and their own 20 electrons, one positive, one negative. This is what is holding all the metal atoms together. This is what is called as metallic bonding. Is that clear? Now these positively charged ions, they are not in the form of ions basically. You are just considering that the magnesium ions and their valence electrons together constitute the metallic bonding. That is what is holding the magnesium atoms together. So these, the so-called Mg2 plus ions, what are they called? They are called as positive kernels. They are called positive kernels, and these are nothing but their own valence electrons. Right? So the interaction between the positive kernels of metal atoms and their own valence electrons will will cause metallic bonding. So this is what you have to first of all know. Now come here. Metallic radius, it is defined as 1/2 the internuclear distance between the two adjacent metal ions in the metallic lattice. So दो metal ions 2 Mg2 plus के बीच में जो distance है उसका आधा, that is called as metallic radius. Okay. Now the force of attraction between the positive kernel and the valence electron is what is called as metallic bonding. I explained to you. Now if you consider metallic radius, van der Waals radius and covalent radius. Now how do you arrange them? Van der Waals radius is larger than metallic radius and metallic radius is larger than covalent radius. So van der Waals radius is the maximum. Right? Now let us see. One second. Let us see now the atomic radii of lithium to neon I have given. 152, 111, 88, 77, 70, 74, 72, 160. So what you find, this is atomic number. Across a period it increases. Lithium 3 atomic number, then 4, 5, 6, 7, 8, 9, 10. This you know. So this is one period I have denoted, and this is one group I have denoted. Lithium, sodium, potassium, rubidium, cesium. Now look at the atomic radius across the period and down the group. Across the period it is decreasing. Then from fluorine to neon there is an increase. Why there is an increase? Because all the orbitals are in the filled state, and between the electrons there will be repulsive forces which makes the size of neon greater. So the decrease in atomic radius is still halogen, and from halogen to noble gas there is an increase in the atomic radius because the noble gases, they have completely filled electronic configuration. And down the group what happens, when the shell increases, then atomic radius will also increase. So atomic radius decreases across a period and atomic radius increases down the group. Noble gases have higher atomic radii than halogens. This is due to inter-electronic repulsions because of the completely filled orbitals. So this is one concept. So across a period it decreases, down the group it increases. Now when you consider an atom and its positively charged ion, same way an atom and a negatively charged ion. Say for example you consider calcium and calcium 2+. Same way you can consider say Cl and Cl-. A cation is smaller than its neutral atom. Anion is larger than its neutral atom. Now why so? If you consider calcium, which is having a configuration of 2882, and calcium 2+ is having a configuration of 288. Same way Cl is having a configuration of 287 and Cl- is having a configuration of 288. Now here what you find, there will be 20 protons and 20 electrons, and in this case there will be 20 protons but there will be 18 electrons. So here in the case of Ca2+, the proton number is greater than electron number. So the hold of the protons will be more tight with respect to electrons. So the size is smaller because of greater nuclear charge. Because of greater nuclear charge. Which is the nuclear charge here? 20 protons. 20 protons is greater than 18 electrons. Initially it was 20 each. Now it is 20 holding on to only 18 electrons. So the hold will be more tight. So the size will be smaller. Now in this case what you find? You have 17 protons and 17 electrons in the case of Cl atom. Now in the case of Cl- what you are having? You are having 17 protons but 18 electrons. So in the case of Cl- you are having proton number less than electron number, right? So what will happen? Proton number is less than electron number. That means 17 protons cannot hold on to 18 electrons that effectively as 17 protons and 17 electrons were doing. So when the proton number is less, then the hold is also weaker, so the size is bigger. Size is bigger. Whereas here the proton number is higher, so size is smaller. Here the proton number is lower, so size is bigger. Right? And also you can say the nuclear charge is less to hold on more number of electrons. That is why the size is bigger. If it can hold tightly, the size will be smaller. If it cannot hold tightly, the size will be bigger. So that is what I have given here. 2882, 20 protons and 20 electrons. 2+ will have 20 protons and 18 electrons. Here I have considered fluorine. I told you about chlorine. It is nothing but the same. So in the case of cation, due to decrease in the number of shells and due to increase in effective nuclear charge. Now when you consider an anion, due to decrease in effective nuclear charge, the size will be bigger. Okay? Okay. Now let us see another topic called isoelectronic species. Now, if you consider Al3 plus Mg2 plus Na plus F minus O2 minus and N3 minus. Now what is their atomic number? Atomic number is 13, 12, 11, 9, 8, 7. This you know it already. Now how many electrons each of them they are having? Al3 plus will have 13 minus 3, that is 10. 12 minus 2, that is 10. 11 minus 1, that is 10. This is F minus, so 9 plus 1, 10. This is O2 minus, so 8 plus 2 is 10. And this is 7 plus 3 is 10. Now all of them are having the same number of electrons. So this is what you call them as isoelectronic species. Those species having same number of electrons. Now how can you explain the size of these isoelectronic ions? Greater the nuclear charge, smaller the size. Now Al3 plus is having 13 protons. Nuclear charge means what? Nuclear charge means number of protons. Now this is having 13 protons, this is having 12 protons, this is having 11 protons, this is having 9, this is having 8, this is having 7. So greater the nuclear charge, smaller the size. So Al3 plus will be having the smallest size and N3 minus will be having the largest size. So remember, isoelectronic species, if you consider, then the size increases. When it will increase? When the nuclear charge decreases, size increases. Here also we explain the same thing. When the nuclear charge decreases, size increases. Here the nuclear charge is more, so size is less. Here the nuclear charge is less, so the size is more.